All right, hey, what's up, guys? Happy Sunday night here, filming you this video from the Section 3.7 Day 2 Double Cpctc problem set. Now, I got one question here. And guys, first of all, I'm surprised. I only have one question in my email right now. There's 6 proofs. There are 6 proofs on the homework this weekend. I was expecting a few more questions than this, to be honest. So, reminder, just go ahead and send me an email, and I'll try to bust out a video, try to explain it for you here in case you're struggling with one. Sometimes knowing how to do one of these or one of these ones that you're really struggling with can help unlock some things in the other ones here. So, anyways, I got this question here. It was about a few other things mentioned in the email here, but nice question here about question number 9. A little bit stuck on it. I think this person was from block 6, the meeting with their tutor, but hey, wanted to see how it works today, right now, if possible. So, let's see if I can go through it kind of quickly with you guys here. All right, number 9 here, I have marked up the diagram a little bit in kind of an unconventional way. I haven't really shown you this in class, but again, the section that we're talking about is double Cpctc. We're not just going to prove one pair of triangles are congruent. We're going to prove one pair of triangles congruent, use Cpctc once, or maybe we use it twice. We're using it twice in this one. And then that's going to help us prove a second pair of triangles are congruent. And then ultimately, the second pair of triangles congruent, that's how we're going to get what we're trying to prove, which is this. To be congruent to one another. So let's go ahead and do it, okay? Quick reminder before we actually we do this here, in this proof here, we got the summary from class, okay? The summary from class is these diagrams and these problems a little bit more complex, right? A little bit more complex than some of the proofs we've seen earlier this year. Part of that is how many triangles are in the diagrams, okay? If you're going to be proving more than one pair of triangles are congruent, you're going to have at least 4 triangles in your diagram. Here, I've just marked off the corresponding pairs of triangles that may be congruent, and we got 3 of them. I got this one in blue here, this one in RSK and XYL, the one in green, and I have one in yellow here, KST and LYZ. So we can kind of think as we're trying to get segment SK congruent to YL, segment YL, well, that would involve either getting the yellow triangles congruent or getting the green triangles congruent, okay? So maybe work backwards here in a second here and see where that kind of helps connect the order that we have to do things. Okay, so here, again, tips for doing problems like these. Work backward. Figure out what triangles you will eventually need to prove congruent, right? I think I just answered that for you here. I'll eventually need to prove either the yellow triangles are congruent or the green triangles are congruent. Well, why? Segment SK, right? Segment SK and segment YL, and those are the ones you are setting off on your pathway in this puzzle here to prove are congruent. Those are corresponding sides of triangle LYZ, triangle KST. KS and LY would correspond, right? Those here. Same thing here too with the green triangle. RKS, XLY, LY, boom, LY right there, and KS, boom, they're corresponding sides of those triangles. So if we can get them congruent, we've done our work. Just Cpcdc, we'd get done here. Okay, first things first, find some helper triangles. Find some helper triangles that would be super easy to prove are congruent first, okay? Step 2. That's already taken care of you in this one here. Step 2, look, that one right there. They actually give it to you, right? They're like, you know what? We don't need to make you do a whole bunch of homework problems where we're actually proving 2 pairs of triangles in each problem are congruent. Let's just say you could prove them congruent. Let's give it to you for free. So here they're giving to you that the blue triangles, triangle RST, is congruent to triangle XYZ. Okay, those big triangles right there. So those are going to be your helper triangles. Those are going to be the ones, right? We're going to say that given in first step, and then we're going to use Cpctc to say that parts of RST, parts of XYZ are congruent. That will help us get the yellow triangles congruent, or help us get the green triangles congruent. Okay, we gotta pick one, right, when we're going through it. Okay. Step 3, use Cpcdc to prove a pair of corresponding parts are congruent and that are in both triangles. Okay. What I think I mean by that is that, well, we know that the blue triangles are congruent. So if we can say if I say angle T is congruent to angle Z, well, that's nice because that's in another pair of triangles. That's in this yellow triangle here, this yellow triangle here. So that could get us one step closer to proving that triangle KTS is congruent to triangle KZY, okay? So we know that the blue triangles are congruent. It's given to us. RST is congruent to XYZ. Cpctc, we could say this, right? Because these, right, that's just angle T right here, which corresponds to angle Z right here. Okay, and that would help us get the yellow triangles congruent too, because they're the same freaking angles that are in the larger triangles are in these 2 smaller triangles down here at the bottom right. Okay, you seeing that? You seeing that? Message me if you have trouble seeing that. Okay, I'm trying to make this trying to go quickly, but trying to make it as simple as possible here too. Okay, so you know what? I think I'm actually kind of committed to this. I'm gonna say this at some point through Cpctc. So my strategy here is I'm gonna try to prove that the yellow triangles are congruent eventually, because then I'm gonna use Cpctc again to get closer to finishing the proof. And that'll be finishing the proof, because you know what, Ly and Ks, as I mentioned earlier, are corresponding sides of the yellow triangle. So if I can get them congruent, Cpctc again is actually going to allow me to finish the proof. I'm not going to have to say anything else after that. Sometimes you do, because sometimes you need to get lines parallel or something else. But in this instance, you don't actually have to do that. Okay, so let's go ahead. I'm going to erase this here. Let's get it back to what you saw at the beginning of the screens here. And let's go ahead and write this, shall we? Let's do it here. Puzzles, baby, puzzles. Okay, that's why this class is a little bit difficult here. It's just not, you don't just follow a list of directions to get stuff done. You got to work through the puzzle of it all. Remain structured, remain organized. Statements, reasons. Okay, step one. Let's figure it out here. Triangle RST is congruent to triangle XYZ. If you followed my game plan that I talked about a little bit earlier in this video here, you realize that I'm trying to get the yellow triangles congruent. Okay, that's my goal, right? Blue triangles given to you is congruent. Yellow triangles, I'm going to try to get those congruent here. So my strategy at this point, let's maybe ignore the other given premises. Let's save them until later. My goal here is to maybe, using this blue triangle right here, I'm going to say in this blue triangle here, the ones that are given to me as congruent, I'm going to try to say as many things in this blue triangle that I would know are congruent to one another that are also in the yellow triangles, in the small triangle. So once again, this blue triangle, this is my help. I call this the helper triangles, the helper pair of triangles, because they're going to help once we use Cpctc to help us get some corresponding parts of the more specific triangles, the ones that actually contain the things we're trying to prove. Okay, so what can we say? Well, step two, what are some things in the blue triangles that are also in the yellow triangles? Well, I told you about the angles here. So CPC, look, angle T, angle Z, look, they're in the same position as we named the congruency here. Okay, so we know that angle T and angle Z have to be congruent. Why? They're corresponding parts of congruent triangles. So Cpctc, we're almost always going to have Cpctc instead immediately after proving congruent triangles, because then we can say their parts are congruent, and that gets us closer to maybe other arguments we can make. Okay, so I'm going to say that angle T is congruent to angle Z through Cpctc. But is that all I can say? Is that all I can say? That with the blue triangle here and with the blue triangle here, that's also in the yellow triangle? What do you notice also this yellow triangle here? Yellow triangle here. What does it have in common with the blue triangle? The blue triangle. The yellow triangle here. What does it have in common? Okay, well, this here, ST and YZ. Look, YZ right here, ST right here. Those two sides are congruent, right? They're corresponding parts of congruent triangles. So I'm just going to assert that right here. I'm going to say that. And how do I know it? Well, Cpctc, corresponding parts of congruent triangles are congruent, definition of congruent triangles. So I'm going to say segment ST is congruent to segment YZ. And that gets me another part. I have an AS. Can I say ASA? Is that going to be that? Oh, we'll get to it in a second here. I can at least have a side. I have an angle. And if I can get another side here, if I can get that side, the two triangles will be congruent by SAS. If I can get an angle here, then it's the two triangles here will be congruent by ASA. If I get that angle and that angle, well, then the two triangles are congruent by AAS. So I've gotten a little bit closer, right? I've gotten a little bit closer, okay? That's all I can do, right? So that's all I can do here with these blue triangles. So I'm done thinking about this given premise. I built on as much as possible. Why? Well, RS, XY, well, that's not part of the yellow triangles. XZ, RT, well, I know that I have KT here, I have LZ here. Well, it doesn't help us show that those two sides of the yellow triangle is congruent. So I've done my job. My helper triangle's done a job, and we're on our way. We're on our way with the other things we can say. Okay, so let's check it out here. The other given premises here, we haven't actually used this, right? You got to think about how is this useful right here, okay? Well, I see that ray SK bisects. Oh, you know what? Yeah, they're actually, stupid puzzles here. But there's another thing that I have to say in this one. Do you know what? Well, let's see. I'm going to go backwards for a second. I'm going to say another thing here first. Maybe this is the thing that you didn't see, and that's why you're messaging me on this one here. There's another thing I'm going to say when involving this proof, and the reason is because I got a bisector of angle RST, right? RST. That's in the blue triangles. What do we know of the blue triangles? Well, they're congruent to each other. Bisector of XYZ here, XYZ here. So I know that XYZ, angle XYZ, and angle RST, I know that they're congruent too. Why? Cpctc. And if I know that I have RST and that's the same measurement as XYZ, then I know that if they got bisected, right? If they got cut in half here, and maybe I'll mark that one up here. Boom, boom. These two angles are going to be congruent to one another. They make up the whole thing. And the whole thing is congruent. These two angles are going to be congruent to one another by definition of angle bisector, so that'll come up in a second. I can actually show LYZ is congruent to KST. Okay, so maybe just, if you're not seeing it, maybe just bear with me. Let's go through a little bit more of this proof, and hopefully you see it, maybe ask questions about me tomorrow when we review it. Step 3 is this here. I haven't actually talked about this. I haven't introduced this given yet, but let's talk about it. We got SK, ray SK bisects angle RST. Okay, ray YL bisects angle XYZ. Okay, and that's a given premise. Okay, I know that the two whole angles are congruent. Okay, what about the partial, the part of it here? Okay, well, part to whole. Ooh, part to whole. This goes back to chapter 1. It's back to section 1.3. So this is really going far back. I want to talk about KST, and I want to talk about LYZ. If I can get them congruent, check it out here. I would have an, switch to a color we haven't used that. I have an ASA correspondence with the yellow triangles. Okay, so how can I do that? Well, definition of angle bisector, I might use it, but I'm actually going to use the angle bisector theorem. Okay, remember the difference between the definition of angle bisector. An angle bisector creates two congruent angles, so that would be a part equals part relationship. The definition of angle bisector, the angle bisector theorem. Okay, that is a part to whole theorem that we proved. It's fact that we proved here. That the part, okay, measure of angle KST equals 1/2. You know what? I might actually do this. I'm going back and forth here. I'm going to change this to angle measurements up here because I'm going to talk about angle measurements in a second. Okay, so I switch those to angle measurements. The measurement of the whole angle equals the measurement of the whole angle up here, Cpcdc. I'm going to compare measure of angle XYZ because I've used it up here. I'm going to talk about measure of angle XYZ as it compares to the measure of the part that got created when we take the bisector YL into consideration. And what do I know? This part here, LYZ, as it compares to XYZ, well, how much larger is XYZ than LYZ? Well, it's 2 times larger. So measure of angle XYZ equals 2 times the measure of angle LYZ. Okay? And that's the angle bisector theorem. The reason why I'm doing this is because, hey, check it out here. That equals measure of angle RST. Okay? So through transitivity, I could say that measure of angle RST equals twice the measure of angle LYZ. And then I can also talk about KST to also involve it with that comparison here. You know, this is angle bisector theorem is an awkward one, right? It's just an awkward theorem to use. Some of us will get it. Some of us will still be working on it, and that's okay. So let's check it out here. Also using the angle bisector theorem down here. Measure of angle RST equals, well, twice. Okay, the whole equals twice the part. So twice times by measure of angle KST. Okay, that is the angle bisector theorem. And step 5. Okay, would be, this would be substitution actually here. Check it out. Here, I got XYZ up here. I also have it right here. So what I can do is I can take this and replace that, what appears in that part of the equation here in step 2 after Cpcdc. I just said that that angle was congruent to that angle, right? The holes are congruent because the blue triangles are congruent. So I can replace that. I can make this 2 times measure of angle LYZ, okay, equals 2 times by the measure of angle KST, okay? And the reason why I can do that here is, well, I have measure of angle RST here, and it's equal to measure of angle XYZ here, measure of angle RST here. I can take what it's equal to and replace it, okay? Take what something is equal to and replace it with something else. That's the substitution property, right? Substitution property of equality. So I got a little substitution POE on that one. Okay, POE on that one. All right, so I haven't said all of ASA yet, right? The YZ, ST, good, I got a side. Angle T, angle Z, right? I set it way back up here. Got another angle. The final angles here, I need to say angle LYZ, and I can do that now. Measure of angle LYZ equals measure of angle KST. And that's just, well, at step 5, I said this. That's just the division property of equality, division POE. Okay, so now I can say the two triangles are congruent here. Why? Because I have, for the yellow triangle, maybe make this yellow, I have an angle, I have an included side, pair of included sides here. The sides are included between the two pairs of congruent angles we have. And then finally, I have the other, right, the other angle, right? So angle, side, angle, right? Step 2, I had an angle on the side. Here, I get the remaining angle down here, okay? All right, so step 7. Okay, step 7, we have here triangle, right on a space down here. Triangle LYZ is congruent. To triangle KST. Okay, reason, that is ASA. Okay, and there we have it. Okay, now we have the yellow triangles congruent to one another. Ah, perfect. Okay, so those were the specific trials. We got to get congruent to say corresponding sides. Look, I got LY right here. Yeah, there we go, YL. LY corresponds to KS. Okay, YZ, YL. Yep, there we go. And then SK. And we're good to go. So we can say here in our final steps, it's an 8-step proof. It's kind of a long one here. We can say that SK. Sure, why not? SK is over here, but that's fine. We can just bring it apart. It's congruent to YL. Y? Well, give me a C, give me a P, give me a C, give me another, a T, and then give me another C there, and we're good to go, okay? Thank you guys for watching this here. Thank you for this question here. I know this was a longer one here, eight steps. You know, when I eyeball something like this, maybe I don't think it's 8 steps here. So best of luck on the rest. Message me if you have any questions. Take care, guys. Bye.